Hi guys and welcome back. Today we will be looking into something slightly different with linear equations and relations. Our first problem is about graphing. It asks us to graph the line 4x plus 5y is equal to 10. We realize that at the moment the equation given is not in slope-intercept form, so we have to transform it. To review, slope-intercept form is when an equation is in y equals mx plus b form. First step is we have to move the x to the right side, so that gives us 5y is equal to negative 4x plus 10. Now we want y on its own, which means we have to divide both sides of this equation by 5. So from that, we get y is equal to negative 4 over 5x plus 2. This is in slope-intercept form. Therefore, this equation tells us that the slope of this line is negative 4 over 5, and the y-intercept is 2. There's now an xy coordinate plane on the screen here. We can plot down a point now, since we already know the coordinate of the y-intercept, which of course is 0, 2. We will call this point A. Now we do not know a second known point, therefore we cannot use that method to solve this problem. Instead, we have to use the slope of negative 4 over 5. Be reminded that slope is equal to rise over run, so we can interpret the slope of this line as saying that when any point on this line rises by negative 4, it runs by 5. Rises up, therefore negative 4 means that it is dropping down by 4 units, as shown on the screen. Then it will run to the right side by 5 units. We can follow this path and get to a point that we will call C. This will be another point on this line. Now we can connect AC, and that is the line that we have found. The next question is related to solving a system of equations. These equations have two variables, and there are two equations in the system, because you need two equations to be able to solve for two variables. It says to use the elimination method. Remember that elimination requires you to get one of the two variables onto the same coefficient, which is the number in front of the variable. For example, if you multiply each of the two equations to have a same coefficient for y, then you would try to cancel the y's out. This way you are able to solve for x, and plug that into one of the two equations to find y. Right now it doesn't matter which of y or x you use, because none of them are easier than the other to eliminate. I'm just going to go ahead and eliminate y. We see that one of the coefficients of y is negative 4, and the other is 3. We know that the lowest common multiple of these numbers is 12. Well, how do we get from 4 to 12? We multiply it by 3. So 3 times equation 1, we get 12x minus 12y is equal to 24. For equation 2, we have to multiply it by 4 to get to a y coefficient of 12, which leads us to the equation 40x plus 12y is equal to negative 76, as shown on the screen. Now, of course, we can see that the two y's have opposite coefficients. To eliminate them, we must add the two equations together so that the positive and the negative cancel out to form 0. When we add the two equations together, we get 52x is equal to negative 52. Therefore, x is negative 1. So we have now solved one of the two variables. And now we have to plug this into one of the two equations. I'm just going to plug it into equation 1. So we replace x with negative 1. 4 times negative 1 is negative 4. Negative 4 minus 4y has to equal 8 according to this equation. When we move negative 4 to the right side, we get negative 4y is equal to 12. We divide both sides by negative 4, we get y is equal to negative 3. So our final answer to this problem is that the point of intersection for this system of equations has a coordinate of negative 1, negative 3. The next problem asks us to solve the system using substitution. Remember, substitution is a different method compared to elimination, but they both have a common goal, which is to solve for the two variables. How substitution does this is you pick one of the two equations, and given the relationship between x and y from that equation, you try to express one variable using the other. This way, you can plug that expression into the other equation, because there are two equations. Now, there is again only the one variable left, which makes it much easier to solve for. The system that we will be working with is shown on the screen. Let's mark the two equations. We have equation 1 and equation 2. Let's plug what we have in equation 1 into equation 2. Equation 1 tells us that y is equal to negative 4x minus 3. So we move that into equation 2 by subbing y into equation 2 as what it says in equation 1. Therefore, negative 4x minus 3 is equal to negative 2x plus 1. Now we just have to solve the equation. We will add 4x to both sides and minus 1 from both sides, which gives us negative 4 is equal to 2x, so 2x is equal to negative 4. Divide both sides by 2, x is equal to negative 2. Again, we have to plug this into one of the equations, so I'm just going to plug it into equation 2. Well, negative 2x would be 4. Add 1 to that, we get 5, which would be the value for y. Put that together, the coordinate of the point of intersection of these two lines is negative 2, 5. Our final problem tells us that a segment has endpoints A, 1, 2, and B, 7, 4. Well, we can call the segment AB. Determine the equation of the perpendicular bisector of AB. Let's remind ourselves of what a perpendicular bisector is. Well, it is defined as a line segment which intersects another segment perpendicularly and passes through its midpoint. Looking at this, the first thing we can do is find the midpoint of AB. Well, the formula for midpoint tells us to have the two x-coordinates for the two endpoints added together and divided by 2, and the two y-coordinates added together and divided by 2. So the coordinate for the midpoint of AB, which we can call M, would have an x-coordinate of 1 plus 7 divided by 2, so 4, and a y-coordinate of 2 plus 4 divided by 2, which is 3. So M is defined by coordinate 4, 3. Now, going back to the definition, we see that a perpendicular bisector must be perpendicular to the line it is bisecting, as the name suggests, which means that its slope multiplied by AB's slope must equal negative 1. We know that the slope is change in y over change in x, so the slope of AB, given the coordinate of its 2 points, would be 4 minus 2 divided by 7 minus 1, which simplifies to be 1 over 3. Therefore, the slope of AB's perpendicular bisector, which we call MN, must be negative 3. Now let's set the equation of MN to be y equals mx plus b. Well, we know the m because it is the slope, so we can fill that in. But now we need to find the y-intercept of MN, which is b. We know that m is a point on the line, and of course we know the coordinate of m, so we can plug that into the equation, swapping x with 4 and y with 3. So from y equals negative 3x plus b, we swap the two sides to get negative 3x plus b equals y. So negative 3 times 4 plus b is 3. So negative 12 plus b is 3. Now, add 12 to both sides. We get b is equal to 15. So the full equation of the perpendicular bisector of AB is y equals negative 3x plus 15. There you have it. Hopefully this lesson has helped you solidify your understanding of linear equations and systems of them. And of course, hope you've enjoyed this video. Next video, we will continue working on this concept with some word problems, which will hopefully help to make these ideas more relevant to real life. But for now, please like and subscribe, and see you guys next time. Bye then!